Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Ali Putra Alika, and today I'm going to explain about my team's project. It's about urban hydroponic water and nutrition feeding system with water usage data logging. Our team consists of Dava Fahri Zaman, Mufti Putra Tama Sumarto, Muhammad Rehan Safero, Muhammad Narendra Hermawan, and also Mia Ali Putra Alika. Okay, since the pandemic COVID-19, many people start to developing a new hobby. Here, we're going to talk about hydroponic gardening that we use in our system. Basically, the hydroponic gardening is gardening without using soil. It's have a lot of advantage, such as it have more frequent harvest, fewer bug, water saving, and it's also have ability to keep your plant dirt free. Using our system, we can add precise nutrition over plant growth and record it using the SD card. The objective of our system is that the sensor can read the temperature, the sensor can determine the distance between itself and the water level. The data can be transferred to SD card. The system is able to display real-time clock. The clock can be adjusted, and also the system is able to log temperature, water level, and as well as timestamp. Okay, that's all for me. The next part will be explained by Rehan Savero.
So first we place the Arduino UNO in the middle, and then the second thing is to connect the SD card module to the Arduino in the pin 13, 12, and 11 and 10 as seen in the video right now. And then we also add virtual terminal that is connected to the TX pin of the Arduino, and we also connect the HCSR04. This is for the ultrasonic ranging sensor to sense the water level. Here we connect the trigger to the pin the second pin and the echo on the third pin. We also add relay. There are 3 relays needed in this project, and we connect the relay on pin 4, 5, and 6. So we left the 7 and 8 pin also as the ninth pin not used. And now we connect the button to the analog 1, the second button to the analog 2. So this button is used to adjust the time that is going to be displayed in the project. Now we also add a temperature sensor, and we connect to the pin A3, analog 3, with a resistor at 4.7 kilo ohms. And now we connect this is an oscillator but also a RTC module, the S3232, and we connect the SDA pin to the analog 4 and the SEL pin to the analog 5, and we ground the DS18B20 to the button as well. Now we also add a power terminals on the third pin of the DS18B20. And next is we want to add the I2C module for the LCD. Now the SCL pin is connected to the SCL of the Arduino. We can now do it in parallel with the DS3232, and now we also ground the A0, A1, and A2 of the PCF at 574. Now the last 4 pin of the LCD is connected to the last 4 pin of the I2C module, and the RS, RW, and E is connected to the pin 1, 2, and 3. And now we connect the motor Now the motor is 12 volts, and that's why we need to use a relay to activate the motor. And we ground the other end of the motors so that it allows the electricity from the generator to flow through the motors. And now we just add generators at the relays, and now we're done.
Okay, my name is Proteus Sumarto. I'm from electrical engineering. Now I'm gonna discuss our project coding on Arduino for the first part. Okay, first thing first, we're gonna include the RTC library, LCD, and SD library with module connection and the crystal LCD. And then we insert the LCD library for the clock for the time, and this is the button definition and define the DS18B20 data pin because we use that. And then this is for the data log, and then this is for the ultrasonic distance that we use to measure the distance of the water mineral B. It consists of two not A and not B with each not A delay 2000 and delay not B delay 5000. And then next up we can on a void setup. There is a button 1, button 2, relay 1, relay 2, relay 3. Memory relay 1, relay 2, relay 3 is the sensor of the distance. And the next one is RTC begin. We need to initialize the RTC chip. And then we also install the LCD module with the custom cursor and a column. We also open serial communication, and then utilize the SD card to save the data log. If it's okay, we create a text file named logs.txt, and we're gonna write the date, the time, the temperature that has been measured, and then the distance that has been measured too. And then if it failed, we print an error creating files. Okay, so next this is the main loop, the void loop. There's the distance. The distance is gonna be 0.01723, and then times the data that has been scanned. And if the distance is more than 50, it will put the digital write the 1 as a high, and it's below 10 as a low. Now we're gonna read the current time and the from the chip, display time and calendar, and we display if B1 is pressed, and we call the debounce function. So we can edit hour, minute, day, month, and year in the program. Uh, Thus, we write time data type to chip. And this condition when if temperature below zero and uh, change the temperature profile to positive form. Okay, next we print data on the PC serial monitor, and this the condition where is the SD card was being initialized, and we open the log.txt that has been created before, and then we close the file, and we put the delay a second. Okay, that's all for the first part. The next part will be explained by my friend. Okay, that's all. Thank you.
Okay, hello, my name is Dava, and I will be explaining about the functions from here on out. So the first one, we have the RTC display. It's basically a function to display the time based on the timestamp that we got from the RTC library, which is the real-time clock. And okay, so first up, of course, from the matrix that we got, we have the days of the week, and then there's the time, which here we can take the hour, the minute, and the seconds. And here on, we also display it to the LCD. Uh, and then after that, we combine the variables into one here. Okay, next up we have the edit. Basically, it edits the time, the RTC time, based on the button that we press. So basically here we have the debounce. It calls the debounce function, which means it waits for the button to be released, and then it changes the parameter.
And if the buttons are still pressed, it will continuously change the parameter based on this algorithm, on these conditions. And then it displays it on the LCD. Okay, next up we have the actual debounce function. So like I said, it basically it's a control for the button 1 debounce, which returns a condition boolean 1 or 0. Okay, next up we have the sensor function. This is the DS18V20 function for that sensor, and it has a delay of 400 microsecond, and then it returns the pulse. It's either a 1 or 0. So it's a boolean, and then we have the write function. It basically writes to the pins that we have. So here it declares it low, and then it uses it as the output, and then we have the DS18B20 write byte. So it basically writes in the form of bit values. And then next up we have the read bit. Same as the last one, but it's to read the function, to read the sensor, and then display it, and then return it as a value, which will be stored in a variable. Okay, and the read byte is the same, but in byte, not in bit. And then this is also the same. So basically, all of here is for the sensor, which are most likely built in and almost always stays the same. Thank you.
The first thing we do is to adjust the time and date, which we can use this button to select what we want to edit, and this button to change the number. This project will record the data every 10 seconds. So every 10 seconds, the data, which is the temperature and the level, will be recorded into the SD card, and we can see it. We can see it in the virtual terminal. So we can change the temperature using this button, which this one will increase and this one will decrease it, and the level is also the same. Using this we can decrease it, and using this we can increase it. Okay, so how this project works is, so there is 3 motor. The first motor represents the water, the second motor represents the nutrient A, and the third motor is represent the nutrient B. So the water of the motor 1 will run if the level is higher than 50. So if we wait. Okay, so the motor 2 will run if the level is below 10, and the motor 2 will also run if the level is below 10. The motor 1 will run until the level is below 10. So if so the motor 1 will not stop until the level is lower than 10, and the motor 2 will run for 3 seconds, and the motor 2 will run for 5 seconds. So as we can see here, it's already 20 seconds. It's already run for 20 seconds. So there is 2 data. The temperature is 40 and the level is 7, and I change it to 50 or 16, and it is recorded here. So we can simulate if I change the level higher than 50, the motor 1 will run, and the motor 1 will not stop until the level is below 10. So for example, if I change it, the level, for example 7, it will stop, and the motor 2 will run for 3 seconds, and motor 3 will run for 5 seconds. We can see the fast recording inside the SD card using Ultra ISO. Using Ultra ISO, and there is a .cv file. Inside here is the data we already taken from last simulation. Okay, I think that's it for my explanation about the simulation of this project. Thank you.